Hi friends, I hope you guys are doing all right. We are getting so close to the end of chapter 6 that I am excited. This section 6A is the second to the last section, so we've got section 6-9 to go. This section is entitled Dilations, which are really interesting and pretty cool, and they build off of a concept that we've talked about before when we were dealing with the coordinate plane. If you remember a situation like this, let me get my pen, a situation like this was called it's kind of like looking in the mirror. It's called a reflection. And we dealt with this earlier in the year. So we had reflection. So sometimes you can reflect things across the y-axis, or in this case, this is also a reflection. You can reflect things across the x-axis right here. Does anybody remember what this was called over here? This was referred to as a translation. So a translation is when you took the figure and you just moved it exactly as it is, just moved, no flips, no turns. And then today, this is what we're going to talk about. We're going to talk about dilations. Dilations are when you can increase the size or shrink the size of something, kind of like your pupils get dilated, same thing with these images. So what we're talking about today is dilations. Here's our vocabulary. Our vocabulary is dilation is a transformation that enlarges or reduces a figure by a scale factor. So we've talked about scale factors before. We know that scale factors were used when we had a model, and we talked about the scale factor to the model to the actual size of the actual thing that we were modeling. So scale factor is a familiar term. We'll see how it's used here. So our first example here is we're looking at a dilation in a coordinate plane, and what we're thinking about is we're going to have a figure J, K, M, N. We'll plot the points, and then we're going to have an image of that figure, and that image will have a scale factor of 1/2. How do we create that is the question. So when you start off with a point of the original figure X, Y, and you know that you are going to have an image that has a factor that's 1/2, so it's going to be scaled down in a sense. You take each term, x and y, and you multiply it by that scale factor of 1/2 in this case. So it's pretty simple actually. So let's go ahead and just do that first. So I'm going to take J. The point J is 2, 4. If I figure out what the image is, and let me do it in a different color. So I'm going to call it J prime. I'm going to multiply each term by 1/2. So x was 2. Now half of x will be 1, or 1/2 times 2 is 1. Same thing here. Y is 4. Half of 4 is going to be 2. So J and J prime are corresponding parts in a sense. So we see that the change has happened. And let's go ahead and do the next couple of them. So K, I'm going to multiply each of the coordinates of K, oh, that's 2, 6. Each of the coordinates of K by 1/2, and I get K prime being 1 and 3. M, which is 8, 6, I'm going to get M prime as being 4 and 3. Again, just multiplying by 1/2 because that is our scale factor. N is given as 8, 2, and I will multiply each term to get N prime, and N prime is going to be 4 and 1. So let's go back. So now all I have to do is plot the points that I have here, and I'll have the image that I've created, and then the pre-image, which is the original. So let's go ahead. 2, 4 is going to be here. So there's the original image. Let's get the the pre-image. Let's get the all right, that took a lot longer than I wanted it to, and I had to do some moving in and out, but I hope that you guys can see that we started off with this figure. We have its image, so here's our pre-image in black, our image is in green, and we just followed along with using the scale factor to change each point. I know that it has kind of moved, but this is not considered a translation. This is really considered a dilation and not a translation. All right, let's take a look at the next example. Okay, here we are in example 2, dilation in a coordinate plane. So a triangle has vertices that are as given. A is 1, -2, B is 0, 2, and C is -2, -1. Find the coordinates of the triangle after dilation with a scale factor of 2. So the cool thing is this should not be too hard for us. We know that what this means is, I thought I had a black one, let me try black. We know what this means is if I start off with the point xy, a scale factor of 2 means that I'm going to take each term in that each coordinate and multiply it by 2. Pretty straightforward. So I go from here to here, and I'm going to use these points. So when I do that, let's try A first. A is given as 1, -2. Therefore, A prime will be given, let's use a different color. A prime is given as, gets bigger, it's going to be given as 2, -4. Let's do A prime there. And I think you guys can do the rest. B is given as 0, 2. Therefore, B prime would be given as 0. When I multiply 0 times 2, it's still, 0 times 2, it's still 0, but the 2 becomes a 4. And finally, C, which we will write here as it's given -2, -1, we have C prime becoming -4 and -2. So that's pretty much all that we need to do for this problem, is really just multiply each term. So it's kind of nice that we didn't have to graph it, because graphing is harder here in the on doing this on the computer. All right, so let's take a look at example 3. Example 3 is going to harken a little bit back to some of the old stuff that we've done, because we know how to compare an original figure with another figure with a model or some kind of a scale drawing, and that's kind of what we have here. So the key here is, so we're going to find the scale factor if the quadrilateral A, B, C, D, that's the smaller one in here, is the pre-image, and the quadrilateral PQRS is the image after dilation. So basically, what you want to do in a case like this, where you're given two pictures on a coordinate plane, is you want to compare the corresponding sides. Now, DA corresponds to SP. We can see that through the lettering here, or we could actually just look at the picture and see that, you know, this smaller one is enlarged to be the bigger one, and it hasn't been rotated or shifted or anything as far as we could see. So what we would do in a case like this is compare the length. So the length from A to D is 3. If you notice, we've gone from 0 to 3. And the length from P to S is 6. So when I take the relationship, I see going from smaller to larger, right, is going to go from 3 to 6. That lets me know that my scale factor is 1 to 2, or 1/2. And that's really it. You might notice that if you take each of these coordinates and multiplied it by 1/2, you would not get the corresponding coordinate, which is true. This picture happened to have been dilated and shifted, and sometimes that could happen. That's why I didn't go for the coordinate. So again, when we are given a picture and we have to figure out what the dilation is, or the scale factor, we use corresponding sides, not going to the actual vertice and trying to figure out what was multiplied. All right, as for me, that's it, and here is your assignment. I'm definitely looking forward to talking to you guys soon. Let me know if there are any questions that you have, and we'll get started with your assignment when you can. Have a good day.